This is Mrs. Wainwright's math class, Chapter 1, Lesson 9, Problem Solving, Word Problems. Today's learning target: by the end of the lesson, you should confidently be able to say, I can use visualization and pictures to help solve word problems. And since this lesson is about word problems, of course, number 1 is a word problem. Most people, when they look at word problems, think, oh no, I can't stand word problems, they're so hard. And one of the reasons for that is we just kind of read through it real quickly, try and quickly find the numbers that we need. Sometimes we know what we have to do mathematical wise, sometimes we don't know what we have to do. We just take a guess, and very often we wind up being wrong. The strategy that I think works the best for a word problem is to really picture it out, almost like a movie or a TV show. That helps you really understand what's going on. It helps it make more sense in your mind so you can kind of figure out what you need to do. In addition, you could take that picture that you have in your mind and you can draw it out. So let's take a look at number 1. Mark works at an animal shelter. I stop after each sentence and think about it. Okay, I'm going to picture Mark. He's got reddish curly hair, blue eyes, kind of tall and skinny, and I'm picturing him at an animal shelter, which is like a building where they have lots of, they keep lots of animals. Next sentence. To feed 9 dogs, I'm going to picture 9 dogs right next to each other. Mark empties 8 18-ounce cans of food into a large bowl. So I picture a table with 8 cans of food. I know I look at the bottom, they each say 18 ounces. And he's got a big, huge bowl. He's going to open them up with a can opener and dump all of the food into that bowl. Okay. Next sentence. From the beginning of the sentence to the comma. If he divides the food equally among the dogs, he's going to take that huge bowl and he's going to divide it among the dogs. I know there are 9 dogs, so he has to divide it among those 9 dogs. The question that they want to know, how many ounces will each dog get? Okay, let's go back and highlight what I know. I want to always underline my question, so I find my question mark and go back to the asking word. In this case, it's how. How many ounces of food will each dog get? That's what I need to find out. What facts do I know? Well, I know there are 9 dogs. I know Mark empties 8. Very tricky. They wrote it in words, but it still is a number. He empties 8 18-ounce cans into the large bowl. I know that he divides the food equally among the dogs. All right? So I have that picture in my head. Let's kind of draw that picture out on paper. I know that there are 9 dogs. Okay, disclaimer here. I am no artist. I can't even draw a good circle. So, this is going to be my best ability of a dog, and then I'm just going to copy and paste it. Here's my dog. Oh, that ear didn't go all the way to the head. Oh well, good enough. I get the point. There's its whiskers and its eyes. There's my dog. Alright, after you stop laughing, we're just going to pretend it's a dog. So there are my 9 dogs. Anytime I have more than 4, I like to count them and write the numbers underneath to make sure I did it correctly. So let's just double check that there are indeed 9 dogs. 1, 2, 3, 4, 5, 6, 7, 8, 9 dogs. Perfect. The next thing I look at, the next fact, is there are 8 18-ounce cans of food. So I'm going to write 18 ounces. I'm going to make a square around it. There you go, there's my can. I need 8 of them. I'll put 4 on the top and 4 on the bottom, giving myself 8 18-ounce cans. I know that Mark's going to open all those cans and put it into a large bowl. That's a lot of food, so I'm going to make a huge bowl. He opens those cans, puts them in the bowl, so I'm going to circle the whole group of cans and put an arrow to show that they're going in the bowl. So my question is, how much food is that? How much food did he put in the bowl? How many ounces? Well, I know that each can is 18 ounces and there are 8 cans, so I'll do the math problem. 18 times 8. 8 times 8 is 64. Put down the 4, carry the 6. 8 times 1 is 8, plus 6 is 14. So I know that in the bowl there's 144 ounces of food altogether. Okay, I know the total amount of food. Now I have to see that food is going to feed all those dogs. How much will each dog get? Well, I know I have 144 ounces, and I have to divide that up amongst 9 dogs. So I'll say the 144 in the bowl divided by 9. Let's go ahead and write that in a division box, because I don't know that fact by right up here, 144 divided by 9. And this is going to be a long division problem, so I'm going to set myself up for long division. First, I have to give Mrs. Wainwright her chocolate bars. Let's look at my first digit. Inside the box, the dividend, is a 1. Is 1 greater than or equal to 9? No. So I'll look at my first two digits, 14. Is 14 greater than or equal to 9? Yes. So that's my first chocolate bar over the 4. Every digit after it gets a chocolate bar. My steps for long division are, does Mrs. Wainwright savor chocolate bars regularly? Certainly. Underline the B, arrow from the B to the D. So now we're going to start with divide. 9 goes into 14. I go through my 9 times tables. 9, 18, up too high. Put my finger down. My answer is 1. Multiply. 1 times 9 equals 9. Subtract. 14 minus 9 equals 5. Compare. Is 5 less than 9? Yes. Perfect. Bring down. Is there anything to bring down? Yes, there's the 4. And after I bring down, I underline. That's the new number I'll be dividing back into when I go back to the top. I go back and divide. 9 goes into 54. 9, 18, 27, 36, 45, 54. Perfect. Exact. 6 fingers up, so my answer is 6. Multiply. 6 times 9 is 54. Subtract. 54 minus 54 is 0. Compare. Is 0 less than 9? Yes, it is. Bring down. Is there anything to bring down? No. So I write a remainder, but my remainder is 0, so I don't write a remainder. I have to circle my final answer, but I stop myself because this is a word problem, and a word problem needs to have words or units. If I go back to my question, how many ounces of food will each dog get? How many ounces? That's my unit. So I will say 16 ounces and circle my final answer. And since there's so much information on this page, in addition to circling it, I'll also highlight my final answer so it stands out. After reading this entire page, because I'll be adding lots of things to it, stop and complete worksheet number 1. Be sure you draw a simple picture. Be sure you show all math work. Include the unit with your answer. And finally, circle your final answer. Good luck with number 1. Let's take a look at example number 2. Michelle, a picture with long brown hair, is building shelves for her room, so I picture her in a bedroom with a hammer, putting shelves up. She has a plank that's 137 inches long. She wants to cut it into 7 equal shelves. So I picture a big long piece of wood, and she wants to make it into 7 shelves. The plank has jagged edges, so I'm picturing rough. Jagged means rough, like they're not straight. Pointy edges. So she'll start by cutting 2 inches off each end. I picture her with the saw, cutting a little bit off one side, a little bit off the other side. How long will each shelf be? Well, let's go back and underline what we know. We have to underline our question, so I find my question mark, go back to the asking word. How long will each shelf be? What facts do I have? Well, she has a plank. It's 137 inches long. She wants to cut it into 7 shelves that are at equal length, so they're the same size. She's going to start by cutting 2 inches off each end, not just one end, but each end. And again, how long will the shelf be? By drawing this plank that she has. And there's my plank, and let's label it. I know that it says it's 137 inches long. And she's going to take this plank and she's going to make it into 7 shelves. Draw my shelves and number them. 1, 2, 3, 4, 5, 6, 7. To make sure I have the right amount, I do. The next thing that tells me that she's going to start by cutting 2 inches off each end. I'm going to make a line for 2 inches off this end. And make another line on the other end to cut 2 inches off that end. So let's see how long this shelf is, because we have to see how long that is before we're going to break it up. So I know that my shelf is 137 inches to start, and I'm going to take away 2 inches on each side. So I'll have 2 inches on one side plus 2 inches on the other side. I'll take that away from my 137. Let's solve this problem. I see that there's more than one operation, so I have to follow PEMDAS. Are the parentheses? Yes. Circle the parentheses and solve. 2 plus 2 equals 4. Bring everything else down. My next problem is 137 minus 4. I can use scrap paper if I want and figure out that it's 133. So after I cut those jagged edges off, my shelf will be 133 inches. Let's go back and fix that picture of the shelf. Cut off one end, cut off the other end, and now what I have left is 133 inches. So now I know I want to take this 133 inches and I want to divide it up and make it into 7 equal shelves. So 133 divided by 7. Let's move that problem over to here and let's set ourselves up for division. 133 divided by 7. I see that this is a long division problem, so I need to do the setup first with the chocolate bars. First digit of my dividend is a 1. Is 1 larger than or equal to 7? No. Move over to the 3 and make it a 13. Is 13 greater than or equal to 7? Yes, so it gets a chocolate bar. Every digit after it gets a chocolate bar. Set up my steps for long division. Does Mrs. Wainwright savor chocolate bars regularly? Certainly. Underline the B, arrow from the B to the D. 7's going to go into 13, 7, 14, too high, put my finger down. 1 time. 1 times 7 equals 7. Multiplied. 13 minus 7 equals 6. I subtracted. 6 is less than 7, so it compares. Bring down my 3. Now I'm going to divide into 63. 7 goes into 63 9 times. Multiply. 9 times 7 equals 63. Subtract. 63 minus 63 equals 0. Compare. Is 0 less than 7? Yes. There's nothing to bring down. There's no remainder because it's a 0. Circle my final answer, but this is a word problem. I don't have room up there, so I'll bring my 19 down here where I have some more room. And I need to figure out what my unit is. I see that in the problem, as I've highlighted in yellow, my unit is inches, so my final answer will be 19 inches. How long will each shelf be? Each shelf will be 19 inches. Please stop and complete worksheet number 2. Remember, we want you to draw a simple picture, show all work, include the unit with your answer, and circle your final answer. Good luck with number 2. Okay, let's see if we can tackle number 3. So let's take a look at number 3. To make concrete mix, Monica pours 32 pounds of cement, 65 pounds of sand, 12 pounds of small pebbles, and 17 pounds of large pebbles into a large wheelbarrow. If she pours the mixture into 7 equal bags, how much will each bag weigh? Okay. Question, asking word, how? How much will each bag weigh? That's what I need to figure out. What do I know? Well, I know that Monica pours 32 pounds of cement. She then pours in 65 pounds of sand. Then she pours in 12 pounds of small pebbles. And finally, she pours in 17 pounds of large pebbles. And she pours that into the wheelbarrow. I know that she's going to pour that mixture that's all mixed up in the wheelbarrow into 7 equal-sized bags. So let's draw my picture. I'll do my cement, my beautiful container, because I'm such an artist. This is cement. And I know that she has 32 pounds. I know the abbreviation for pounds is LBS, period, so I'll use the abbreviation. I know she also has sand, so here's my sand container. I'll label it sand, and she has 65 pounds of sand. It also says that she has small pebbles. I'll make my small pebble container, abbreviated small, and there are 12 pounds of that. And I know that there are large pebbles. Here's my large pebble container. I abbreviated large, and there are 17 pounds of large pebbles. So I know those are all the things that she has, and she's going to pour them into her wheelbarrow. After she pours it into the wheelbarrow, she's going to take what's in the wheelbarrow and she's going to make it into 7 equal-sized bags. So I'll make my smaller equal bags. 1, 2, 3, 4, 5, 6, 7. Number them to make sure I have 7. 1, 2, 3, 4, 5, 6, 7. I'm good. I have 7 bags. So now, How much is going to be in each bag, or how much will each bag weigh? Well, I need to know the total that she's pouring in. So to find the total that she puts in the wheelbarrow, I'll circle all of the things that she's putting in, give myself an arrow to show that that all goes into the wheelbarrow. How much will the stuff that's in the wheelbarrow weigh? Well, let's add it together. 32 plus 65 plus 12 plus 17 will give me the total weight. I look at my ones column and I look to see if there are any partners of 10. I don't see any, so I'll start to count in order. 2 plus 5 equals 7. Oh, and I know 7 plus 7 is 14, so I'll jump there. And 14 plus 2 is 16. Put down the 6, carry the 1. I move to my tens column and I look for some partners of 10. I don't see any, so I'll add 1 plus 3 is 4. Oh, well, 4 plus 6 is 10. Plus 1 is 11. Plus another 1 is 12. So I know that the weight of my wheelbarrow will be 126 pounds. I'm going to pour that into these bags. How much will be in each bag? Well, I have my 126 pounds divided into 7 equal groups. And let's go ahead and solve that with long division. 126 divided by 7. Long division, so I need my chocolate bars. First digit in the dividend is a 1. Is 1 greater than or equal to 7? No. Move over to the 12. Is that greater than or equal to 7? Yes. So the 2 gets a chocolate bar, and every digit after it gets a chocolate bar. Set up for long division. Does Mrs. Wainwright save her chocolate bars regularly? Certainly. Underline the B, arrow from the B to the D. Let's start to divide. 7 goes into 12, 7, 14, up too high. Put my finger down. I have 1 finger left, so my answer is 1. Multiply 1 times 7 is 7. Subtract 12 minus 7 equals 5. Compare, is 5 less than 7? Yes, it is, and that's good. Is there anything to bring down? Yes, I have to bring down my 6 to make the new number of 56. Go back and divide. 7 goes into 56. 7, 14, 21, 28, 35, 42, 49, 56. Perfect. 8 fingers up. It's 8 times. Multiply. 8 times 7 is 56. Subtract. 56 minus 56 is 0. Compare, is 0 less than 7? Yes, it is. Is there anything to bring down? Nope. Remainder, it's 0, so I don't have one. And I know for my final answer, it's a word problem, so I will need a word. I don't have much room over here. But let's go back to my problem and see what my word should be. I have 32 pounds, 65 pounds, 12 pounds, 17 pounds. My unit is going to be pounds. So I'll make room, an arrow to where my room is. And I will write my final answer, which is 18 pounds. Each bag will weigh 18 pounds. Please stop the video and complete worksheet number 3. Remember, draw a simple picture, show a work, include the unit with your answer, and of course, circle your final answer. Good luck with number 3. And our final question is question number 4. Sometimes you'll see a question like this. What if she pours the mixture into 6 equal-sized bags? How much will each bag weigh? There's only one number there. I don't know how to solve this problem. Stop and think logically. She's pouring a mixture into 6 equal-sized bags. How much will each bag weigh? Doesn't that kind of sound familiar with the last problem? Yeah, let's go back and look at that last problem. The last problem was all about Monica, all of the things she puts together. So it's a step 2 of the previous problem. I know that in this first problem, in problem number 3, Monica put all of the things together and she poured it into 7 equal bags. They're saying, what if she did 6 equal bags instead of 7? How much will each bag weigh? Well, I can take my facts and information from the previous problem. I know that when she added all of those things together, everything she has right here, she had 126 pounds, and then she separated it into 7 bags. So I'm going to take that 126 pounds, move it over to the next problem, and instead of dividing it by the 7, I'll divide it by 6 equal bags. 126 divided by 6. So let's go ahead and set that up for long division. 126 divided by 6. I need the chocolate bars. First digit in the dividend is a 1. Is 1 greater than or equal to 6? No. Let's try the 12. Is 12 greater than or equal to 6? Yes. So 2 gets a chocolate bar and every digit after it. Steps for long division are: does Mrs. Wainwright savor chocolate bars regularly? Certainly. Underline the B, arrow from the B to the D. And we're ready to divide. 6 goes into 12, 6, 12, perfect. 2 fingers are up. That's a 2. Multiply 2 times 6 is 12. Subtract 12 minus 12 is 0. Compare, is 0 less than 6? Yes, that's good. Is there anything to bring down? Yep, bring down my 6. Go back and divide. 6 goes into 6 one time. Multiply 1 times 6 is 6. Subtract 6 minus 6 equals 0. Compare, is 0 less than 6? Yes, that's good. Is there anything to bring down? Nope. Is there a remainder? No, because we don't write a remainder of 0. And 21, what's my unit? Well, I don't see a unit in this problem, so go back to the original problem, and my unit, we said, was pounds. So it will be 21 pounds. Not a lot of room there. I'm going to rewrite it neater. 21 pounds, and that will be my final answer for number 4. Please stop and complete worksheet number 4. Remember to show all work, include the unit with your answer, and circle your final answer. So as a review of this lesson, when we're working with word problems, it's a good idea to use visualization and pictures to help you solve a problem. Simple pictures like we did here with Mark in the animal shelter, my adorable dogs that really look like dogs, huh? My cans of food, my bowl. Draw out your pictures. It helps you see what you need to do. Remember to show all parts of your work. And again, in a word problem, your final answer needs a unit, so you have to go back into your problem to find what that unit is. Good luck with this lesson.